Okay, well, hey, thanks for coming to this afternoon session on building reactive pipelines. Just really quickly, I would ask, because I have a lot of material I'm going to try to fit in as much as I can without just like throwing stuff. You know, I want to make sure that everything I cover pretty well, but there's just a lot here to go through. So if you would hold your questions to the end, and if we don't get enough time to address your question at the end, please do see me afterward. Happy to talk at length. As you probably know, I'm very introverted, very shy, but anyway, and I know those are distinct. But anyway, please do see me afterward. If we don't have time to address your questions during the session, happy to talk about it. By the way, the best way to reach me after that, because if you're like me, things come up later, and 10 minutes after you walk off, you realize that that's the question you really wanted to ask, or you have feedback. Because I have given this talk in two different formats before, one in English, one in Spanish, and both were different than what I'm doing now because it evolves, right? But if you have questions, comments, or feedback, I would love to hear from you. You can reach me via email at mark@thehecklers.com or mheckler@pivotal.io. The best way, though, to reach me is on Twitter at mkheck and then Spring Noticias if you're a Hispanohablante. But if not, that's cool. Just reach out to me on Twitter. If you don't want to blast it publicly, that's fine. My DMs are open. So please do ping me any way you can, any way you want to. So, who here has had their boss come up to them and say, you know, you did a great job this past year. I was wondering if you could back off the gas a little bit, not do quite so much, and let me double your budget. Yeah, that's never going to happen, is it? We're always asked to do more with less. Or hopefully more with the same, but generally more with less, right? Because every time we hit a goal, the expectations increase, and that's fine. So how do we do that? And that's kind of what I want to address today. Just kind of here are the high points, and I'll be going through these as we go, and then we'll code them, right? We'll code through some of this and help bring it to fruition. So we'll talk message brokers and streaming platforms. We'll talk about Spring Cloud Stream, why you use it, what does it bring to the table, if anything. We'll discuss reactive streams and Project Reactor. Again, what does that add to the equation? We'll talk about how actually bringing the two together, bringing the two together gives you kind of a big step up in terms of scalability, overall scalability. And then look into the future a bit and see kind of where things are headed and how we can turn it up to 11, so to speak. I'm a big movie and TV quote buff. Anybody recognize that one? Oh, good. Okay, well, a couple people. I'm an old guy, and, you know, again, I have no life, so, okay. Before I get into the who am I, though, I'm really crazy impressed with this crowd, so do you mind if I do a quick speaker selfie? I like to do this because then it proves to my boss that I actually was doing something versus just like going and soaking up the coffee scene, which, by the way, I do that too, but anyway. So everyone say spring. Wow, that was really terrible. Okay, let's try this side and see if we can improve on that. Okay, let's see, is that? My photography skills are just, again, even worse. Okay, so spring. Okay, all right, well, one of those should turn out. Okay, so who am I and what makes me semi-pseudo, sort of almost qualified to talk about this kind of thing? I've authored several blogs and blog posts. I've co-authored a couple of books. I've contributed content and code to several other books, some of which actually even recognize my contributions. That was nice. Many didn't. That's okay. I wasn't planning to live off the royalties anyway, so that's fine. I am an architect and developer, and as you might guess from the next bullet point, where most of my expertise has been it's been in the Java ecosystem. I am a Java champion as well as a groundbreaker, as well as a few other recognitions and awards you probably haven't even heard of, don't care. I am a professional problem solver. That's not my official title, it's just what I do, as do you, right? And I am, of course, officially a Spring developer and advocate with Pivotal. So that's kind of the 10-second overview of who I am. Let's get into the good stuff. And I'm going to be frequently, I am a two-fisted drinker. I brought my coffee and my water. The water to soothe my throat and the coffee to soothe my soul. By the way, I love this time slot. This is the absolute best time slot of the day because everybody has just come from lunch. Their stomachs are full, it's a nice warm room, and we're all at peak energy levels, right? Yeah, that's what I thought. Okay, cool. So, in the interest of time, I'm going to make a few rather necessary assumptions here, but if you don't understand anything that I lay out as an assumption, it's not your fault. It's perfectly fine. Just catch up with me afterward, and I'll explain kind of where I'm coming from in that regard. For starters, I'm going to assume you understand the benefits of moving in whole or in part from a monolithic architecture to a microservices-based architecture, even if you maintain some monoliths within your organization, and there are many good reasons why you might do so, or at least a few good reasons why you might do so. Or maybe just one good reason why you might do so, right? It makes you money and you can't unplug it. Whatever, that's fine. But whatever the case, even those monoliths will need to communicate with external services. And what often happens in that regard is that we press a REST API into play. REST APIs have numerous benefits as well, and I suspect you can point out a few of them. Most of us probably know about Jeff Bezos' infamous memo from several years ago requiring all functionality within Amazon to be exposed as services via service interfaces, kind of creating the concept of microservices before they were cool, right? You may also be well aware of the 12-factor manifesto. If not, again, that's fine. Come see me afterward, we'll talk. The upshot, though, is that REST APIs have enjoyed pretty extensive use in connecting various different systems and applications. And for the most part, they work and work well, right? But they're not always ideal. For one thing, performance and scalability are limited by many things. For instance, both services must be online and accessible at the same time. Sufficient numbers of instances of each must again be created pretty much in lockstep, right? To meet traffic surges and spikes. And the network connection must remain stable and sufficiently performant throughout all of the request-response exchanges. And that always happens, right? Yeah, always. Yeah, so we're done. Anyway, but if the network were to drop out, right, or if an instance of one service or another crashes, what happens then? So we see there are many potential weak points that we could maybe address with a better option. Messaging platforms reduce or eliminate these concerns in various different ways while improving your architecture in several other ways. Messaging platforms benefit from being a part of your critical infrastructure, which means that typically your critical infrastructure team or your cloud provider maintains those alive and online at all costs, right? They also come typically with fully configurable delivery guarantees, retention settings, and what have you, which means that it ensures that any message that's sent is received and verifiably delivered, even if no consuming service is available at the time that the message hits the pipeline, right? Message producers and consumers are separated locationally and temporally. And again, I mentioned that the consuming service doesn't necessarily need to be online at the time that the message hits the pipeline, but the consuming service also doesn't need to know or even care where that message came from. It just cares that it has a message that it needs to consume. Scalability dramatically improves, right? Because you don't have to scale them in tandem. If you need more consumers, if you need more producers, you can scale those up independently one of another. In short, anytime you need greater performance, scalability, reliability, and resilience, a messaging platform probably hits your conversation pretty quickly, right? Now, there are many options in messaging, and yeah, I guess I'm still covering that. I was going to say, should I? Yeah. The big ones, kind of the top 5 in my estimation, are RabbitMQ, Kafka, Amazon Kinesis, Microsoft Event Hubs, and Google Cloud Pub Sub. There are many others. But I kind of consider these the top 5. And among those, the first among peers, I typically consider RabbitMQ and Kafka, typically because they're offered on a variety of different platforms by different cloud providers, by the vendors themselves. Not in the case of, well, I guess in Rabbit, yes. But Rabbit primarily implements AMQP, Advanced Message Queuing Protocol, and others. But for business, that's kind of the big one, right? And of course, Kafka, the Kafka API has been used and leveraged throughout various other competing offerings. So the two are fairly ubiquitous, the protocol itself and the API, one from one and one from the other. So I kind of consider those the first among peers. They also tend to have the most established track record, footprint, whatever you want to say. So I typically look at those first, but the others obviously are players as well, again, with others too. So launching into what is Spring Cloud Stream? Why even use it? Well, as you might imagine, one size doesn't fit all. Perhaps your company has standardized on RabbitMQ, or perhaps Kafka, or Kinesis, or what have you. Maybe some of your requirements are handled by different ones. We never have to plug the stuff together, do we, right? So it's a possibility. Maybe your company standardized on one, let's say RabbitMQ, and you acquired a company which standardized on another, let's say Kafka. So how does that work? Wouldn't it be nice if you had a uniform way to deal with various different messaging platforms without having to focus specifically on the messaging platform? Well, it turns out you do. Spring Cloud Stream provides a powerful, opinionated, but extensible way of abstracting above that. So you can focus on the business problem at hand, the problem domain, the thing that will keep your company going and satisfy your customers, versus maybe learning more and tweaking and configuring Kafka replication, let's say. So how does this work? Well, binders make all of this possible. You add a binder library specific to your underlying messaging platform, provide any required or desired configuration settings, and Bob's your uncle, you're off writing code to solve your real problem. Spring Cloud Stream is based on a couple things, Spring Boot and Spring Integration. Spring Integration provides consistent but versatile hooks to various different things. Spring Cloud Stream actually focuses on the messaging platforms part of that. And Spring Boot, say that 3 times fast. Spring Boot provides 3 basic things, among other things: auto configuration, simplified dependency management, and ease of deployment. So it makes, again, our lives as developers much easier. So let's see, Spring Cloud Stream, again, does most of the heavy lifting for you. Now, the nice thing about that is that you can switch messaging platforms. So if your CTO reads a tech magazine, sees an article online and says, Kafka, that's the way we ought to be going, even though last week I just told you to standardize on Rabbit. If you have the ability to swap that out with a simple change of dependencies and rebuild, that would be awesome, wouldn't it? You also have the ability to do dynamic changes, so you can switch dynamically from one to the other, should you have that kind of foresight. Hopefully none of you are in that position where you have to have that level of responsiveness. You're not being pulled that quickly and hard in different directions that frequently, but if you are, you know who you are, so that capability is pretty handy to have. Okay, so reactive streams and Project Reactor. I'm actually going to kind of hit that and the next one rather quickly together, because at this point, it's like, okay, that all sounds pretty good, but what does reactive streams and reactive programming really, how does that factor into this? So let's step back a bit. What is reactive programming? I love this quote by one of our Project Reactor team members, Rossen Stoyanchev, and he kind of sums it up really nicely. Pardon me for a moment, I'm going to have to strip. I promise I'll only take off my jacket, so it's safe. Nobody run out screaming. Oh dear, I'm hooked. Oh, we're good, okay. Oh, we're not good, hold on. Oh, you know what? Watch this, look at that. Okay, thought it was gonna end badly, it won't. Okay, so, Rossen said, in a nutshell, reactive programming is about non-blocking event-driven applications that scale with a small number of threads, with back pressure as a key ingredient that aims to ensure that producers do not overwhelm consumers. Now that packs a lot of information in one statement, which is why I love it, but let's unpack it just a little bit so we can actually kind of understand it in full. The Java way of scaling for several years has been very good, very easy to reason about, very easy to understand, relatively speaking. I mean, you know, it is still scaling. But you typically, for each additional connection, have an additional thread, right? So one thread, one connection, roughly. What happens is that scales really well until you hit that n+1, right? If you have n threads and you have n+1 connections, what happens? At that point, your performance kind of goes into that hockey stick shape, right? So at that point, you have blocking that occurs. Somebody has to wait for something else to finish before they can take off. Now, of all those threads, what is happening at any given point in time? Nothing, right? They're blocking. They're waiting for a response from another service or a file system or a database or what have you. So at any given point in time, we have a lot of threads doing not much. They're blocking. They're waiting. So it's easier to reason about, but it's not maybe perhaps as efficient as it could be. We've seen from the node folks how efficient you can be with a single thread, how much throughput you can have. The problem is, of course, with a single thread, what happens when you have a bad actor? Everything stops, everything, completely. So we ideally would want the ability to have an event loop inserted in there, being handled by across a small number of threads, hopefully handled optimally for us by a scheduler. We obviously will want to be able to tweak those levers if we want to, but in most cases that should kind of happen for us automatically. Let's see, back pressure. Something else I was going to mention, I'll probably think of it later, so I'll just continue. Back pressure is a key ingredient. Now, so far we kind of talked about things, and it sounds a lot like asynchronous programming. Anybody done asynchronous programming? Asynchronous programming has a couple of problems, right? Just, again, to highlight the top two. One is legibility, readability, right? Anybody heard of the term callback hell? Yeah, that term was coined by an optimist. That is the best of all worlds, right? If you don't know what callback hell is, that's great. Keep living the good life. That's fine. The other part of that that's a little bit of a problem, or a big problem, as the case may be, is that in asynchronous programming, you have no guarantees of how to address a slower consumer and a very prolific, a very fast producer. So if you have a producer of values that's shoving 1,000 values per second down the pipe, and you have a slow consumer that can only process 10, what happens? That slow consumer typically just falls over and dies, right? There's no pushback. There's no way to signal, look, I just can't deal with that volume. With reactive programming, you have back pressure, which is a way for a slower consumer to say, look, I can only handle 10 values at a time. Just give me 10. And when I'm ready, I'll ask for 10 more, or 50, or 100, or whatever the case may be. It doesn't change the fundamental fact you have a very fast producer and a very slow consumer in that particular case. But what it does is shift the control back to where you have some control, right? We may not necessarily have control over an iPhone client 2 countries over, but we do have control over our cloud service. So at that point, we can make some educated decisions. What happens with the other 990 values that that slow consumer can't process? Does it matter? Maybe it's a real-time dashboard and we just drop them. Maybe we want to buffer them and set certain buffer characteristics, but that, at least we have that ability to do that versus the old days of asynchronous only programming where you really didn't, right? So it gives us a few additional tools in our tool belt, I guess is what I'm trying to say. And by the way, that's all based on reactive streams, the Reactive Streams Initiative, which was kind of, a lot of companies came together and agreed on this, different implementations, yes, but they all are compliant. They all demonstrate a cooperative nature and are testably, provably compliant with the reactive stream spec via the TCK. So you had companies like Pivotal, Kazing, Twitter, Netflix, Lightbend, Red Hat. So a few small companies got together. But rather than solve things in incompatible ways, we're working together to make this easier, because if we don't, who gets caught in the middle? Us, developers, right? This all should work. So I like this quote. Actually, it's from the Reactive Streams repo, the README. The purpose of reactive streams is to provide a standard for asynchronous stream processing with non-blocking back pressure, which again sounds oddly complementary to the whole streams, right? So a little more information about the Reactive Streams API itself. It's a very simple API. That's why everybody can kind of come together and agree on this. It's very granular. It's 4 interfaces. That's it. So you have a publisher of things of type T. So that's the thing that produces things, right? You have a subscriber, which is the thing that consumes things. You have a subscription, which is the contract entered into between the consumer and the producer, right? The subscriber and publisher. And then you have a processor, which actually incorporates the capabilities both of the subscriber and the publisher, because a processor will accept values, manipulate them, and pass them on. So yeah, kind of makes sense. Now, in the imperative world, for instance, when we have a return value from a method, we might return an object of type T, a thing, right? Or we might return some kind of an iterable of type T, a collection, if you will. So maybe a small group of things of type T. The reactive world is similar. You'll have similar use cases. And within the Spring team, we felt it made sense to specialize that publisher interface, right? So if you're expecting a value, 0 or 1 values, we call that a mono. It's a type of publisher. You know that you'll have 0 or 1 values at any point. If you have 0 to n values, that's a flux. So you may have a small collection. It may be an indefinite number over an indeterminate amount of time. And some operations apply equally well to both. Some don't. That's the specialization. So, and just to kind of clarify a bit, within Spring, we're not replacing the blocking the imperative code. That's Spring MVC. We created separate parallel packaging. So Spring Web Flux versus Spring Web MVC packaging. And its parallel capabilities, which means it's pretty frictionless to switch between them, which is nice, again, for us developers who have to spend a lot of time in both worlds. So the first time I did this talk, I just kind of launched into code, and some of the feedback I got was it'd be really helpful to understand kind of what you're doing before you do it, and I think that's a valid point. So this is kind of a quick overview of how I'm going to be developing things. Within Spring Cloud Stream, you have 3 interfaces that implement the contracts via binders, right? You have a source, a processor, and a sink. A source, again, is that thing that creates and pushes things into a pipeline. A processor manipulates and passes them on. A sink actually is the end of the line. That's where something is done, and that's it. That's the terminus. Now, if we compare the two, streaming with reactive streams, we see a very nice parallel, right? That's cool. because in the Reactive Streams API, you have a publisher, which roughly equates in the Spring Cloud Stream world to a source. It's the thing that produces and creates things. You have a subscriber, which is kind of a sink. That's the thing that receives it, receives the end-of-line things. A processor, which equates to a processor, right? That was nice. And a subscription kind of is implemented by the pipeline itself. And I use the term pipeline because that keeps me up out of the exchanges and queues versus topics. The concept is roughly similar, right? So let's code. That's my seat, right? That's the hot seat. Everything I do, I code live, which is really exciting. The good news is if I ever do hit anything weird that I have never hit before, which does happen on occasion, I have a lot of help. So that's good. I will mention that the front row, the folks in the front row especially, I particularly appreciate you being there, because I tend to, as you might have noticed, I hide it well, I know, I talk fast. I type fast too, which means I typo fast. So if you see any typos before I hit build, please stop me and tell me, and if not, it's on you, okay? Okay, no, nobody bid on that one. Okay, well, anyway, we'll just go with that. All right, so let me change this to where I'm mirrored. One time I actually didn't do that, and I'm just charging away, and people are like, I see nothing, so that's a little embarrassing. All right, so we're going to start here. Let's see, let's put that up. So used to, I would say, hey, everybody recognizes this, but this has changed recently, right? This is a Spring Initializer. If you're not familiar with this, that's cool. We changed this a little while back. If you have any questions, comments, or feedback about that, please do reach out. We're refining, we're polishing as we go. You don't have to go to the Spring Initializer to create Spring Boot-based microservices. It just launches you faster. So if you want to hand code them, that's great. But nobody's boss ever gave them a raise based on hand coding everything. They gave them a raise on implementing functionality their users requested. So I suggest you start here. Yeah, preference. So I'm going to go with the simple defaults for today. We're going to create a Java project using Maven and the current version of Spring Boot 2.1.4. I'm going to change this to the Hecklers because I can. And then we're going to implement the three interfaces or a microservice for each of the three interfaces that Spring Cloud Stream exposes, a source, a processor, and a sink. And then we're going to have some fun with it, right? We're going to show kind of how this all works together nicely and reactively. So I'm going to choose my dependencies just based on the start typing and let it match thing. So I'm going to bring in the dependency for reactive web. Any Spring MVC developers here? So you're familiar with like the default for Spring MVC applications in Spring Boot is Tomcat, right? But you can swap that out, Jetty, Undertow, Netty, whatever, or Jetty, Undertow, I should say. So the same thing here, right? Netty is the default engine, the default reactive engine that we use. But any Servlet 3.1 compatible engine will work. So Tomcat, what is it, Tomcat 8 and up. Undertow, Jetty, that's fine, but Netty, well proven, well tested. So we'll stay with that. And of course, it gets the WebFlux capability. I should point out that Project Reactor is the underlying dependency. So you can use that without using Spring. I don't know why you'd want to, but you can. But some folks actually do use Reactor with Android and what have you. Not that that's a supported use case, but we find that it does happen. So if that's you, great. But WebFlux brings in those Project Reactor bits. So I've got reactive web. I'm going to bring in the reactive cloud stream. And as you can see here, it points out that we need a binder. So Kafka, RabbitMQ, Kinesis, what have you. I'm going to bring in Rabbit, and we'll just start there. And I have some other stuff that if we have time, I'm going to slide into and do, but we'll keep this on the main line first, and then we'll branch out from there. I'm also going to bring in Lombok because I'm a lazy developer. Lazy good, not lazy bad. I've had a love-hate relationship with Lombok, but it does allow me to cut through to the boilerplate and just show you kind of the important stuff, and again, cut through it and get rid of the fluff, so to speak. So we'll go here, and let's see, I'll go out to my desktop, unzip, and then we will open that in our favorite IDE, NetBeans. Kidding. I like NetBeans. Please don't take that wrong. I pick on my friends. NetBeans has great Spring Boot support via plugin. Eclipse has, well, Eclipse is an IDE too. So if you use it, that's great. But anyway, I mean, we do actually have a build of Eclipse called Spring Tool Suite. It has great cloud deployment. I do like the cloud features in it. IntelliJ fits. So we'll go with that. I'm going to switch this to presentation mode, even though IntelliJ freaks out when you have multiple projects in presentation mode. So when I do bring up another one, you'll see this kind of slam, slam, slam back and forth. Close your eyes so you don't get seasick. I'm talking to the IntelliJ folks to try to get it resolved now. So As with everything. Okay, so the first thing I'm going to do is just go to my application.properties file, which is where I set sensible defaults, right? So I'm going to start off with my server, set my server port equals 0. Yeah, I get that's visible, right? Folks in the back? That doesn't work in presentation mode. Okay, well, if you can't see it, please yell. So I'm going to set my server port equals 0, and then, again, this is my source. And a source does what? It produces values. So it has certain channels, you can have, I should say, certain channels defined in Spring Cloud Stream Apps. For a source, we have one channel by default, which is our output channel, right? So I'm going to just bind, use my bindings to output, and you can set your content type. Our default, of course, is application JSON, so I don't really need to set that. That works perfectly for our cases, our use cases here. And I'm going to set the destination to processor. And I just realized something. I wonder if because I usually like to run this locally. I didn't start up Docker. So we'll let that start while we go ahead and code, and then I'll go back and rerun the applications here. Okay, so I've got my destination set to processor, and that's good enough. Let's go ahead and just start with our application coding. So the first thing I'm going to do is create my domain, right? So class. They say to talk about what you know. And as you might imagine, as a developer and advocate, I spend a lot of time in airplanes, in airports. And I have kind of a mixed relationship with that, right? I love to be places. I love to be here. I'm not necessarily a fan of the airplane experience, right? But it's a necessary evil. So I thought, I always do talks on coffee, because coffee is my passion. And I thought, what else do I know intimately, for better and for worse? And it's flying, right? So I'm going to create an application or applications, a system that could possibly be used by my favorite airline to make life just a little bit better for its customers. We'll see. I'm sure they'll be banging down my door. Okay, so this will be a customer, and this customer will be created upon check-in at the desk, right? So when you go into the airport, you check in or you check in online, this customer record will be created. So we have things like private final string ID and name. We'll keep this really simple. Again, I'm using Lombok, so I'll just add @data and @Constructor, and that for the @data annotation makes this a data class. So it'll have things like getters, setters, equal, hash code, and toString methods. The Constructor annotation for Lombok just says, hey, create a constructor with all arguments. So any member variable, create a parameter for that member variable. So it's kind of nice, handles that nicely. And that'll do for our domain, for our source. We're going to keep this, again, fairly simple. What I also need, though, is a way to generate customers, just for an example, so we can see them hitting the system, because we actually, surprisingly, don't have this wired up to any desks at any airports yet. So I'm going to create a customer generator. Front row, you're going to have a workout today, I can tell. Customer generator. And let's see, I'm going to create an array of strings. We'll call this names. And we'll just use some names. So we'll go alphabetically here. So Aaron, right? Belinda, Carla, Dennis, Eugenio, Francine is the best part, right? Let's see, George, Harold, Irene, Jorge, Kathy, spelling counts. Leona, Mark, Nikhil, got to get in there somewhere, because otherwise, I don't fly, right? Oscar, Philomena. Okay, so that will stop there, because that should be enough just to get us going. I'm going to split those up based on the comma space, and there we go. I'm also going to create a random object here, so rnd equals new random, so we can inject some randomness into this. And then I'm going to generate what? I'm going to generate customers with a generate method. Generate. Return new customer. We'll use UUID random just to generate our ID. And then we'll take our names, right? And we'll just do a random.next int, and we'll use our names.length. And that should generate us some customers, okay? So that's our generator. Now we just need something to push it into the pipeline. So what I'm going to do at this point is enable binding, and we're going to bind to our source class, source, and make sure I grab the right one here. That's important. .class, and this will be our customer sender. We'll call this our desk agent, because this is when it all basically kicks off, right? Okay, so we need to inject our customer generator, so we can use that. Now, we could do field injection. That's a bad practice to get into in Spring. We could do constructor injection, and we could create our own constructor. But again, we're using Lombok. We're lazy. So I'm just going to ask Lombok to provide a constructor with all parameters, all member variables, and voila, we're done. Nice. Okay, so the next thing I'm going to do is create a post-construct method. So upon creation of this bean, this will kick off, and this will return a flux of customers, right? And we'll just call this send customers. Yes, okay, so return flux dot, and we're going to create a flux that produces a pulse at a certain interval. I'm just going to use a duration of seconds, so 1 per second. It'll just do a pulse out there, right? Now, we can map that pulse to create something of value, but what we should do as a good practice, a good habit to get into, is to define what happens on back pressure. So if you're dealing with a slow consumer, what do you do with the intervening values? Now, we know at 1 per second, we're probably not going to overwhelm anybody, but again, good practice. So I'm going to, in this case, I don't necessarily care about what happens to the intervening values. I'll just drop them. But again, you have options, right? You have various different things you can do here. Well, up here on back pressure. We'll just drop them for now. And then I'm going to take each of those pulses and just map them to a new customer. Actually, I don't even have to do that because I have a generator, right? I'll just generate them. That's it. So that's our source. Now we have everything set up to prime the pump and send the values down the pipeline. So now let's go back and create our processor. Same thing goes here. We'll need the same dependencies. We'll just change this out to the name of processor and save it. And go here and unzip that. And open that up. Oh, it didn't do that. That's so weird. Okay, well, once in a while you get lucky. Come on. It's just not playing along. Oh, come on, IntelliJ. Oh, there we go. Okay. And the one thing that I didn't do is go ahead here and do a start messaging platforms, and that way we actually have something to pass through. If we have time, what I'll do is show connecting to a cloud-hosted instance of Rabbit as well. But again, that's very similar. You just add a few parameters to your application properties, and you're off and running. So again, we'll start off with our application properties, server.port equals 0. That way, what that does is when a Spring Boot application starts, it'll find a random open port, and it'll just start it there. That way you can scale out with multiple instances of the same service, and you don't have port conflicts. Kind of nice. This is a processor, right? So it will have an input channel defined by default and an output channel defined by default for you. And you can define your own channels, by the way. This is very versatile. Generally, you can mix and match and assemble these in various different ways between sources, processors, and sinks, and that does like 90+% of your use cases. But should you need to define your own source, sink, or processors, you can. You can define your own interfaces that you can use, which have maybe, let's say, multiple outputs or multiple inputs or both. So that's all very easily done. You just create something that has multiple subscribable channels and or message channels, and you're off and running. But we'll stick with the basics, because again, that covers that 90+% use case. So I'm going to define the bindings for our input channel. Destination is, once again, processor. And actually, I'm going to define the group as well. What this does is set it up for a competing consumer group, implementing the competing consumers pattern, which means, again, you can scale out. If you're not competing, what that typically means is if you have multiple subscribers to that queue, they all get the same copy of the same message, right? Which means you don't really scale. You can have 1 or 10, and they're still all just grabbing all the messages. But if you have a competing consumers implementation, what that does is they take turns, which means you can scale out quite dramatically. So we'll do that, and that's our inputs, our gazintas. And for our gazoutas, we have our output channel, our destination. In this case, we'll just send this to a pipeline we'll call sync. And then for our processor, we have a really cool new capability, which I think is really, again, really good. It's very powerful, which you can define what happens to transform each of these messages coming in via a function definition. We'll come back to that. So let's go to our application, and let's again define our domain. In this case, once again, class customer, private final string ID name. And again, this is Lombok. So at data, at alargs constructor, boom. Now that's coming in, right? So this is what happens when a customer is checked in to the airline. But what we want to do is somehow transform these customers so that our gate agent eventually on the receiving end of this, as our sink, can do something special for our customers, because we all know how much airlines care, right? By the way, did anybody fly in? Anybody take the train in? I mean, it's all basically the same, right? I mean, you're all super valued customers. Everybody's happy to see you for coming on. Yeah, okay. So we're going to change this customer. We're going to transform this customer into a flying customer, because the assumption is that once they've checked in, they head to the gate, they truly are getting on a flight, right? So class flying customer. Okay, so let's see, private, final, string, ID, and name once again. But we need to somehow establish a state that this customer is in so that our gate agent can decide what to do to demonstrate the value that that customer shows and gives to them, right? So I'm going to just very quickly set up an enum for state. And let's see, we'll have a state valued. So this will be our valued customer. We greet them fondly. We wish them a nice day. We ask how their day's been. That's nice, right? That's just a nice touch. And then we'll say we have certain premium customers, and we'll just randomly choose customers to surprise and delight. So maybe we'll give them an upgrade from terrible seating to marginal seating or something like that, right? So that's something, right? We'll just randomly choose. Hey, what's your name? John, congratulations. You're a premium customer today. Please come with us, and we'll sit you in a slightly less terrible place. That's something, yes, right? So, this is random. It's just a nice thing to do. So that's what we'll do. And we'll add a field for that, of course. Private, final, state. Clever, right? Okay, so this is a processor, so we need to transform these values. I'm going to enable binding to our processor. Our processor class, customer transformer. Wow, spelling is not my thing today. Oh, okay, so what do we need to do here? Well, again, this is Spring Cloud Stream 2.0, so we can define beans that allow us just to turn them loose on the customers as they come in. So I'm going to create a bean here, and this implements the function, right? The function interface, and a function is a functional interface, right? Hang with me here. So we're going to be receiving customers, and we're going to be turning around and producing a flying customer from each. So let's see, we'll call this add state, because we're going to be adding the state and seeing who we're going to surprise and delight, like John here, right? So with a functional interface, with a single abstract method, what can you do? Ever since Java 8, you can provide a lambda as implementation, right? So that's what we're going to do, return cust, and we'll just say, new flying customer. We'll take our cust.getID, and we'll use that for the flying customer's ID. And then we'll take the customer's.getName, and that's fine too. And again, let's do this a little bit randomly, so it's fair, right? So we'll just do a private final random rnd equals new random. And let's randomize things a little bit. So we'll do rnd dot next int. And we'll say up to 5. So 0 to 4, if that equals 0, if we get a random number of 0 out of that, we'll say our customer state is premium. Otherwise, we still value them, right? So they're a valued customer. We greet them happily and send them back to their terrible seat. But that's sufficient, right? So now we have our add state, we have our transformation, our function, and then we go back to our application properties, and we just paste that there. Simple stuff, right? There are options here, and we'll show you those as we go along too. But now we have our processor set up to run. So let's go back and quickly create our sync, and then we kick off the party. Sync, boom, sync, open, and let's see, application properties, server.port. There we go, 0. This is our sync, so it has an input channel, right? So bindings input.destination equals sync. And once again, our group, same thing. And in this case, we have a function definition we'll fill out as well. So let's go back to our application. Now, in this case, we're just getting flying customers. We're receiving flying customers from our processor, so that's all we really need to define here at data, at args constructor, class, flying, customer, enum state valued, and premium. Okay. And private final string ID name and private final state. Perfect. Okay. So now once again, at enable binding. In this case, we're binding to our sync interface, right? Class. We'll just say this is our gate agent. This is the end of the line, right? So our gate agent will process each of these customers as they're received. And again, we'll define a bean. This implements a consumer interface, right? And a consumer, once again, is a functional interface with a single abstract method, so guess what? And we're going to be consuming what? Flying customers. And we'll just log it. We'll log each one. So let's see. So return, we'll take our customer, and we'll just say, we'll log it. So we can actually even simplify this even more with a method reference. Super, right? Now we just take our log it, and we go back to our application properties. Boom. Let's fire this up. This is the fun part. This is where the wheels count. I mean, everything goes well and perfectly, and it looks great. Okay, so we have our sync running, and that actually did work. Surprise, surprise. Okay, so here's our processor. We'll go ahead and start our processor as well. We've got tons of time, 9 minutes. We're going to have a great time with this, assuming nothing breaks. Front row, you didn't let me down, did you? Okay, good. So we're running with our processor. Now let's go to our, oh, come on, IntelliJ. Let's go to our source. There we go. Let me just pull that out of presentation mode, and that way everything is maybe a little happier. And it took me back to the processor. Brilliant. Okay, so let's go ahead and run this. Give me time for a drink. And what we should see is values that are being passed through our processor to our sync. So if we go to our sync, we see nothing. Oh, I know exactly what happened. Okay, front row, we're going to have a little talk. Okay, so we've created our method here, our post-construct method, but we haven't indicated anything like that this is a stream emitter. It's kind of important, right? We need to tell it to push this into the pipeline, and we need to tell it where to go. So our output channel, of course, is source.output. That should work a little bit better. So let's try that again. In the meantime, we'll flip over to our sync. Look at that. We have values coming through. We have flying customers that are hitting our sync. Our gate agent now sees these and sees that we have a lot of valued customers, and occasionally we get a premium customer in there, which is exactly what we'd expect. John, guess what? It's your lucky day. So that's good, right? Maybe we can do this a little bit better. So let's go back over here to our source, and we'll stop the flow for a moment. Now, I mentioned to you I fly a lot, right? And again, I love being places, don't necessarily love the flying to get there, but I was thinking there should be a special Mark rule. Because, I mean, I spend a lot of time on airplanes, so I'm thinking, you know, they should give me a little love, right? I mean, that seems fair. So let's see what happens if we want to do another transformation. And right now we've defined a bean that does our transformation from customer to flying customer. But let's see if we can improve on this a bit. So let's define another function. But in this case, instead of operating one at a time, we get a customer, we transform it into a flying customer, we pass it on, one per. Let's take a flux of flying customers, because we'll just pass this on, we'll chain these operations. So we have a flux of flying customers, and we'll transform those into another flux of flying customers, right? And we'll just call this treat Mark. Why not, right? I'm sure this will work. So at this point, what we want to do is do something a little special, right? So we're going to, once again, return a lambda. In this case, we'll return, and we're taking a flux in, right? So we'll do a return flux dot, and we'll map each of the values coming in via this flux to another flux. Now, this is the cool thing about Spring Cloud Stream. It does this automatically for you. So if you're kind of making that transition from an imperative to a reactive world, it'll handle that kind of meshing for you until such time as you can go completely reactive, which is also another nice little bonus. So I'm going to take this, and for each value, what I'm going to do is, let's see, we'll take a flying customer, and we'll take that and create a new flying customer, and we'll use the flying customer dot get ID, right? And the flying customer dot get name. Now, about that state, I think we could do better than that, because this is still pretty random. So what would be ideal is if we could just do this, guaranteed upgrade. Now, that's in an ideal world, right? Here's really what happens, because there's no way that would ever fly. What would really happen is additional security screening and seat by toilets. This is my world, okay? So this is really what's going to happen. I just know, and I'm not going to name my airline because they're all pretty universally horrible anyway. So we'll just say that if the fc.getName dot equals ignore case Mark, right? So if that is satisfied, then we'll just assign this state dot additional security screening seated by toilets, and if not, we'll just use the existing state coming through, because that seems fair anyway, right? So that's what's going to happen. I'm going to be seated by the toilets yet again. Okay, so we're going to take that, and we need to actually add that in to our application properties, so that's a treat mark, right? So we'll just pipeline that. Looks a lot like Linux, right? So treat mark. It feels so good to be special. Okay, so we're going to go to our sync now, and I'm just going to add that in here. Again, as a valid option here, and there we go. Now we're all set. So I'm going to go ahead and restart this, and go back to my processor, and we'll restart that. And then we'll go back to our source. Come on, IntelliJ, work with me. And we'll restart that. And then we'll go back and see how it all works out in the sink. Or the toilet. Oh, I have a problem here. Let's see, what's my problem? So this is the sink. Log it, that hasn't changed. Interesting. Okay, front row, help me out. Oh, that's my sink. Hold on. Oh, whoops. That is my sink. That's exactly what I need. Hold on. So we've got the processor, which is processing things nicely. The source is working. So hold on. Let me restart my sync. Maybe I just didn't restart here. There we go. Okay, so we're running. Not sure what happened there. So now we can see if this really worked. We're getting our valued customers, our premium customers. So far, so good. Oh, there's Mark. Right there. Yep, right by the toilets. Just look for me there. I'll be back there enjoying the ambiance. Okay, so at this point, what have we covered? We've got 3 minutes left. We've already covered, again, the sources, the processors, the working with the processors in terms of just one value per, or in terms of fluxes coming in, fluxes coming out. What else can I show you really quickly? Oh, I do want to show you in the sync. Again, there's actually a way that you can do this too. I'm dealing with one customer coming in, but you can do the same thing if you do at bean, consumer, and let's say a flux of flying customers, and we'll just, yeah, that's cool, log it. We'll just keep things consistent here, and return flux, flux.subscribe, and we'll just do system.out, typing.out, print line, and then we just comment that, restart, and it all, again, works the same. So it's very versatile, and it helps you make that transition, again, from that imperative world to the reactive world. Now, once this works, of course, yeah, so everything works, as you might expect, because you never make mistakes when you code. Okay, so let's stop this, and let's go back, and we'll finish up with the slides, and then we'll go grab some coffee. Okay. So the takeaways. Again, we kind of covered all these things, message brokers and platforms. What is Spring Cloud Stream? Why use it? What's the value that it brings to you as a developer? Reactive Streams and Project Reactor. Again, what value do they add? Spring Cloud Stream and Reactor. Again, how does that help you scale? Turning it up to 11. Now, all this shows you how you can hook everything together with reactive, with publishers, for instance, and subscribers. The thing that you have to make that fully reactive throughout every bit of the pipeline is you have to have a reactive, you have to have an asynchronous driver for your messaging platform, and you have to have a reactive binder. So that's in progress, right? Everything is there. The only thing, the last bit that's missing is that end-to-end push. So it's all 100% reactive through the entire pipeline, and we're this close. So part of that is I need to spend less time in front of the toilets on airplanes, and we'll help finish that off. But do subscribe, do follow me. If you're not following me on Twitter, why not? Follow me on Twitter, and you'll be able to keep up with the announcements on just that topic. There it is, MK Heck. And the repo with all the code, plus some, is out there under Building Reactive Pipelines. The Spring Cloud Stream documentation, Project Reactor, same thing. All this is 100% open source. Now, you don't have to go pull down the bits and build them, but you can. That's great. If you have code you want to contribute, that's also great. Ask first in case something's already being worked. But join in, right? We're big on community. And if you, again, questions, comments, feedback, emails, or better yet, Twitter. I live on Twitter, right by the toilets. So thanks for coming, and see you around, DevOps. Perfect.